Hi everyone, and welcome to a fairly quickly organised seminar jointly hosted by SPREE and the Centre for Energy and Environmental Markets. And for those of you who don't know me, my name's Ian McGill and I'm one of two directors of SEAM. And Alan is in town, and it just seemed too good an opportunity to get him out here and to get some of his perspectives on, I'm going to call it possible energy futures. The work still lies ahead in creating what we want to see.
Yes, we've got to finish the war first, don't we? Yes.
I first came across Alan actually when I was doing my PhD, but when I started here as an academic in 2001, Alan was already considered one of the wise old men of sustainable energy.
Thank you.
I don't know what that makes you now. A wiser
ancient.
And has really been doing work. For some of you here will have known Alan from really the very early days. He's worked across government, academia, including RMIT and consulting. And he's been spending the last couple of years really building up, I guess, a set of international perspectives around the possibilities ahead of us. So please join me in welcoming Alan.
Thanks. Okay. Well, thank you very much, Ian, and I'm very pleased to be able to visit you. I've been here for the Energy Efficiency Council's conference the last 2 days, which has been a great success and very exciting. So what I thought I'd do today is a bit of an adaptation, given that this was fairly last minute, an adaptation of a talk I presented October last year to the APEC Energy Ministers in the Philippines. And in fact, this was our Energy and Environment Minister, Josh Frydenberg's first international trip. And so he was exposed to me talking about how I saw our clean energy future before the coal industry really got to him. And he was actually very enthusiastic and rushed up at the end of my talk with questions about the slides and gave me his card. And I have dealt with his advisors a few times since then, but not much else. So anyway, that's how it goes. And I am watching with interest how he'll say one thing one day and a very different thing the next day, and it sort of is a bit reminiscent of what Mr. Trump is getting like. You know, he sort of says, "Oh, we're going to build a wall. Oh, maybe it'll be a fence. Maybe we'll just move on." So it's a very interesting time for all of us. So anyway, so this talk really, I was asked to talk about the future of clean energy in the Asia Pacific. So that's the sort of overall thrust. It was a kind of an opportunity to look at what are the underlying trends and issues that are playing out here, and to talk about how I thought it all worked, because the way I think the energy system works is pretty different from most people. So it was kind of interesting to have 30 energy ministers in the room while I explained to them how it works. So we'll see what you guys think, and as we go through, I'm not sure how informal we can be, but I'm very happy to just answer questions or be distracted as we go. We'll see. Okay, so title slide, a few interesting pictures. I put the human-powered vehicle there because one person pedalling, the world record now is 138 kilometres an hour. Now, how many watts can one person produce? This is pretty efficient. And the whole idea of having that there is to just show that extreme efficiency can redefine reality. And, you know, whether it's a mobile phone, which is another example of extreme efficiency, redefining reality. You know, this is, to me, is the big excitement about energy efficiency, is that it upends people's perceptions of what's possible. And that's really what I'm most interested in as I go through these things. Now, where am I? Okay, I'll go there. Yep, okay. Okay, so the first thing is, we don't want energy. And in fact, a cubic metre of natural gas is not much use to you without some technology to burn it. All right? So energy is just one of a number of important inputs to the delivery of services. And so the key thing to think about, as far as I'm concerned, is what we're really doing is we're trying to provide services like nutrition, entertainment, access, stuff. And we're doing that with a whole range of end-use technologies which keep changing. And so our demand for energy is really a consequence of our desire, because often it's not even a need, it's a desire for services. And so the demand profile and the amounts and the kinds of energy are all up for grabs, because really they're an outcome of how our world works and how our society works. And then there's a role for the energy supply sector to provide what we need. Except that in Australia and most of the world, we've actually got the cart before the horse, because we focus on building all the supply capacity without thinking about the demand side. And in fact, if you reflect on the recent debates after the South Australian mess and a few other recent things, you'll find all of the discussion is about reliable supply, and no one actually talks about why we need it and how reliable it needs to be and all those other things. So I find it fascinating, and of course there's good historical reason, because historically we supplied, say, electricity by building big power stations, which took, in Victoria, 10 or 15 years to design, build and make work. So if you also had a situation where historically the demand for energy was growing, and so you kind of needed to plan ahead. What's exciting today is that we have so many adaptive technologies that we no longer have a need to plan ahead for energy more than maybe 3 years. Because as long as we're tracking what's going on, we have the flexibility to respond. So we are freed up enormously, because I don't think anyone could tell you what the demand for electricity in Australia will be in 5 years. Probably even next year. Right? So we've got to have a whole new way of looking at all of this. And the way we do that is we start by thinking about what do we want. Now, the other thing that's important is that the energy sector is nowhere near as special as many people in the energy sector think. Every sector is special. That's what I find when I talk to anyone who's really involved in anything. It's special. And energy is no more special or less special. And the key thing is that if we look around our society, we see that there is disruptive technology flying around in every area of our economy. The internet, virtual solutions, green chemistry, new materials, urbanisation, everything's changing. And the reality that's fascinating is that the energy sector has been so slow to be impacted by these incredible changes that are going all around us. And it says something for about how bloody minded a lot of energy people are, that they have been so slow to be impacted. Because certain people in this room have been trying to get them to shift for a long time. So, you know, we need to kind of take a good look at the energy sector and ask them, you know, why are we running a massive multi-billion-dollar welfare program for our electricity network operators? This is mad. But that's what we're doing. And most of the people involved in energy policy don't realise it's a welfare program for those incumbents. They actually think they're entitled because they're very special. So anyway, that's kind of where I come from, right? And a good example of this, I think, is if you look at the successive energy forecasts from AEMO from 2011, where you know, it's taken until 2015 to finally confront the possibility that demand might not grow. That's pretty shocking. And you can see each year it's just gone down and down and down, but the fundamental trend was up And it's like, just think about it. If you had invested in a brown coal-fired power station in 2011 based on that forecast, how good would your business case be when you finally open it? Because it still might not be open. This really does reflect this struggle that the energy sector have, coming to terms with the possibility that not just the future might be different, but the today might be different. I find it lots of fun. And so this is the latest set of projections, and they are kind of confronting the 2016 forecast is the black dotted line, and look, it's flat. Now, of course, people like me sort of look at that and say, but what if electricity and gas demand keeps declining at, say, 2 or 3% per annum? What does that do to your forecast and to the decisions about investment and all this other stuff? And they don't know, because they are still living in a world of hope that their forecast is good enough to drive investment decisions. Well, good luck, guys. I can't forecast this, and I have been working, it's 39 years in this space. I can't forecast it, and I don't want to try and forecast it, because there's lots of many wonderful things I don't know about yet. Okay, so what are the key energy drivers? I've already said we don't want energy, we want we want our needs for services satisfied, whatever we think they are. And the way we interpret our needs for things is very interesting, because we are all victims of our past experience. And I think, one of the things I've been doing recently is travelling, visiting a lot of different countries. And what a whole lot of other people think is really normal, I think is really weird. And I realise what a lot of things that I think are normal are really weird to them. So this is the whole point. It's a very subjective thing, what our needs are. In Melbourne, we need a ducted gas central heating system, and preferably 50 or 100 halogen lights in most houses too. Whereas, in Africa, my need for shelter might be pretty different. So these are the things we need to open up in our brains. And the exciting change that's gone on is, historically we have been in our society pretty much been able to put lots of things into boxes. And in fact, I find it funny, because a lot of the economists used to talk about, people were talking about the oil crisis and all that, and they'd say, don't worry, we'll have substitution. The problem for them is they think of substitution in terms of product and tangible things, like a different source of oil. And what's happening is substitution is now possible with virtual solutions, with service solutions replacing products, with tiny products replacing big products. All sorts of substitution is now possible, and in a way it's the dream of the economist to have perfect potential for substitution, but they haven't got it. They don't know how to cope with it. So it's kind of interesting to me to think about substitution. And of course, what that means is that in terms of energy, we're getting lots of different things happening. And what we're getting is integrated combinations of things that are really different. First of all, there's the reframing of what our needs are. Do I need to travel 150 kilometres to visit my friend, or can I Skype them or even talk to them on my mobile phone? There's a whole lot of stuff different. We are seeing diverse business models and redefinition of markets, so that Telstra has now got the guy who used to be CEO of PowerShop looking at how Telstra becomes an energy company, among other things. We've got, Google and Amazon and all these people who don't have a problem with becoming part of the energy sector. We've got IKEA festooning its buildings with PV and making money exporting the power. All of these things are all different, and it's going to be diverse business models. I've argued for some time that the combination of Harvey Norman, Samsung and a really major builder will transform residential energy. with free energy and a house full of super efficient appliances and storage and PV on your roof, and it'll be free because you'll build it into the mortgage. And Samsung will get great benefits because it'll know all about how its products work in the field, and it will know when you might be ready to buy another Samsung product. There's a whole lot of value add going on here, and I think the energy sector are a bit slow to understand that most of the value adding going on in our economy is not by the energy sector. It's by the services sector, in fact. So, diversity, we'll be much more efficient with our use of energy and resources. We will manage demand in sensible, smart ways, and it may even be done for us by someone or something else. We will store energy in many forms, and everyone's all excited about batteries, but there's lots of other stuff too. And we'll have distributed and diversified solutions, which will be really different from what we've had. And different places will come up with different solutions. You know, we manage it in everything else. Why not energy, you know? Okay, so this is my model of how energy works. And there's a few interesting things here. You'll note that we've got a whole lot of elements in the system that delivers a service that happens to include needing to use a bit of energy. We have a whole lot of energy markets. And again, I still can't believe that people can, in revered publications, put rooftop solar at very expensive price per megawatt hour right on the same graph as coal-fired power at a very low price per megawatt hour and keep a straight face. Because rooftop PV is competing with 30 cents a kilowatt hour. Wholesale coal-fired power is competing in a wholesale market where it has historically been 4 cents a kilowatt hour. These are totally different markets. Absolutely different. And yet they put them on the same graph. Astounding. Anyway, so everyone's competing in a different price, and in fact at the retail sector what's interesting is that energy is competing with a whole lot of other things that people value much more than energy. You know, I don't know many people who buy their television based on energy efficiency when they really need a big screen TV next weekend so they can have all their friends over to watch the grand final. You know, likewise, if you look at the operating cost of your television and compare the cost of being connected to Netflix and all these other things to the energy cost, energy disappears. Right? We're in a different space here. And so one of the challenges, of course, if we are trying to improve energy efficiency is we've actually got to understand all the things people want. I talked with an energy expert in China once and I said, "Did you buy that laptop because it's an energy efficient laptop?" And he'd never thought about this, of course. Oh. And then I said, "Well, did you buy it because it was lightweight, had a long battery life and it had a great screen?" "Oh, yeah, that's why I bought it." Where's the energy efficiency in that? Well, without energy efficiency, it can't be lightweight. It can't have a long battery life, right? So we're in there, but we're delivering things that often energy people don't even understand we're delivering. Okay, so what's exciting here is storage can occur at any stage in this system. Generation can occur at any stage in this system, and of course energy efficiency can too. The diversity we have in choice is amazing. And I am waiting for someone to come up with my induction cooktop with built-in supercapacitor storage, or maybe a box that I have in my kitchen which gives me my kitchen-based storage system. Why? Because if you buy an induction cooktop, it's rated at 12 kilowatts peak capacity, and my electrician says, "Sorry mate, I've got to charge you $1,500 to run an extra cable from the fuse box to the kitchen." Hang on, where's the wholesale electricity market in this? I don't understand. And so, as far as I'm concerned, a storage system that can limit the peak demand of my induction cooktop to the capacity of a single power point it's competing with $1,500 that I would pay the electrician. Right? We've got to start thinking about what we're really trying to do. And this means we're in very different spaces. So, so it's really important to explore all of this and to play with it, because I repeat, when you see all these variables, you can see why all sorts of people will have all sorts of different answers, which is great. Isn't that what, society's about? Diversity and creativity and all that stuff. Okay, this slide is my attempt to try and think through the differences between centralised energy systems and distributed ones on a whole range of criteria. And I won't try to go through them all now because we're nearly halfway already and we want questions and stuff. But the key thing about it is, with a distributed energy system that's got that's modular and is manufactured, you've got economies of scale through mass production, not through making it bigger. You've got flexibility of rollout. If demand for electricity is not going the way you thought, or there's someone else coming to the marketplace, you slow down the number of wind generators you plant or the number of rooftops you cover with solar or whatever. Or if demand's going higher, you say, gee, we better stick a few more of these things in, crank up the factory. The capital required is totally different, because we have small lumps of capital that are actually much more manageable, and you get a cash flow from the time you plug in your first rooftop solar unit. You don't have to wait 15 years. So the whole capital structure is totally different, and it's much more in the retail space. You start learning from the time you plug in your first LED light. You don't wait 10 years to build the plant and then start trying to work out what you did wrong. You're getting feedback the whole time. You're learning by doing. You can have a lot of resilience. So if something fails, one person's in trouble, not the whole state. At the same time, distributed systems can be just as bad or worse than centralised ones, and overall system efficiency of a lot of distributed systems can be pretty bad too. So you've got to do them properly. But the key thing is, when you look at this list of criteria, it's obvious why distributed systems are winning. We have a war on, but the distributed systems are winning because they've got fundamental advantages over these centralised systems. Okay, some quick examples. This is a thermal storage system prototype in South Australia for a cold storage facility. And what's interesting here is they were using phase change materials so the tanks were not too big. But once they put the tanks in, they then redid the numbers on solar, rooftop solar, which hadn't looked that fantastic at industrial prices. But because the storage meant you could run the compressors for the chillers when you liked, you could export or import energy, you could do all sorts of different things. Suddenly you had a controllable system which could give you a 20% internal rate of return with a prototype. Just, once they actually get into mass production, what happens to the price? So, of course, you should be using super efficient chillers and a whole bunch of other things, but we don't have many idealised integrated solutions, but these guys are doing some interesting stuff. Okay, aluminium smelting. Aluminium smelting, is pretty big globally. And what's interesting is we should first of all talk about how much aluminium we actually need. And I think we need a lot less than they think we do. And there's lots of things, like one of the really interesting things in Melbourne, some researchers have actually 3D printed a jet engine, and it works. And once they 3D printed it, they realised the next one will be much lighter, because 3D printing avoids all of the small flaws that you get when you machine things. So you don't have to make them as big and as bulky, because you can assume higher strength from the material. There's all these amazing synergies and interactions and stuff that go on. So there's a whole lot of things, and of course we should use recycled aluminium, which we're not that good at. So then, what can we do to produce aluminium if we want to? Well, there's a great US program called APEC. It's a US government R&D program. It started off, it had about 410 projects. It's got 565 now. And I mean, you know, for unusual people like me, it is amazing what is there. Lots of new battery chemistries. I'm not even sure lithium's a good investment now after reading what's coming. But for example, they came up with, they're funding 3 projects. One by Alcoa, one by the Gas Technology Institute, and another one by one of these, you know, small startups that never achieve anything. And they're all aiming for basically 50% savings. There's a fair chance one of them will come through pretty soon. And you're talking about pretty major change. And if you look at the Alcoa one, what they're proposing could well tie in very well with solar thermal, concentrating solar thermal, because the kinds of temperatures and the kinds of things they're wanting to do with storage could have some interesting potential. So, you know, we had a guy from Shell telling us all about why we're going to still need coal and gas in 2050, and we're going to have to just make, you know, large-scale carbon capture and storage work because there's all this thermal energy that we need. He hasn't heard Skip Leitner talk about the post-Promethean era. And in fact, I've just been looking at steel stuff. You know, people are working out how to make steel, how to reduce iron oxide to iron and then steel using electricity, just like you do with aluminium, right? Aluminium oxide to aluminium metal, electricity. Iron oxide to iron metal, electricity. You can do it. It's a bit harder. Well, they're working on it, and that's MIT. Pretty interesting stuff. Whoops. Okay, heat pumps. I really like heat pumps. Heat pumps reconcentrate energy and therefore raise its temperature. And they can capture energy in latent heat of water vapour and other things in ways that we can't at the moment really in most technologies. What I also like is that the Japanese have worked out how to fairly efficiently produce industrial steam using what we call cascaded heat pumps, multi-stage heat pumps. Not rocket science, been used around the world for, you know, since they worked out the Carnot cycle. So these kinds of things are coming through and they open up all sorts of opportunities. Like in Victoria, we're spending tens of millions of dollars running gas pipes out to country towns so they can have food processing plants. If we can package renewables, storage and advanced heat pump technologies and a few other technologies, we could build the all-electric, high-efficiency, renewable food processing factory, and we can free everyone of the need to waste all this money running gas pipes everywhere. So there's some pretty interesting stuff with heat pumps. Then in terms of residential, this is based on some work I did a while ago, where the blue bars are showing you the typical energy use for a 2 to 3 person all-electric home in Australia using technologies that are basically average stock, right? These are not worst, these are about average stock. The orange bars show you what you can do with the best products that are on the market. They're not necessarily the cheapest, but they're on the market and, you know, commercial products. And the grey bit shows you what we could actually do if we just got a little bit focused in a few years. We could do much better again. And so you can, once you look at this kind of stuff, it is astounding what we find. For example, one of the big problems we have with, say, fridges is that a lot of refrigeration equipment is faulty, but it still keeps the food cold enough so you don't realise it. And this is where I was talking to people over lunch. You know, it's not rocket science to build a little module that just tracks ambient temperature and load conditions, monitors the consumption and just benchmarks the actual consumption against a dynamic model that says this is how I should work. And if the difference gets big, you flash lights and jump up and down, or even shut yourself down and say, I'm not going to work anymore because I'm broken. You know, there's all this stuff, and this can be for buildings, appliances, you name it. And of course the car industry and some of the air conditioners and things like that, and some building people are starting to do this. It's not rocket science. But honestly, when you look at the amount of energy that's wasted because stuff is either broken or clogged up, or, you know, someone's driving it in mad ways, it's astounding. This is why there was a great UK study a few years ago that basically concluded that globally we only get useful services out of 12% of all of the primary energy used in the world. Right? 88% losses. And I think they were generous about the efficiencies in a lot of them. So, you know, again, you talk to a lot of energy people and they say, oh, we're pretty efficient already, we can't do much more. So energy efficiency is this kind of fringy thing like renewable energy used to be. Well, sorry guys, enormous savings. And I mean a laptop computer, you know, 90% savings. Big yawn because an iPad or a mobile phone is much more efficient and it does a lot of the same stuff, replaces the laptop. Okay, now I won't go into this in detail, but again, one of the big problems we have as policymakers is that we tend to focus on market mechanisms, pricing and regulation as the big solutions, and they're not. First of all, we need multiple packages of different policy tools for different circumstances. And second, there's a hell of a lot of policy options available to us. And in fact, some of the most powerful policy options are tweaking policies that are targeting something else so they also save energy. For example, you know, we've been spectacularly unsuccessful at getting governments to adapt first home buyer incentive programs so that you get more money if you build a smaller, more efficient home. What could be simpler? We're spending, well, some states have removed them, but you know, we're basically giving all these people all this money to build houses that are becoming liabilities. We could give them the same money on condition they build houses that were assets for the future. What a radical thing that would be. So there's lots of policy stuff around, and we're just appallingly bad at all of it, really. Okay, what's possible? Well, this is the International Energy Agency's pre-Paris scenario from June last year, and you'll notice that energy efficiency is 49% of the bridge scenario, which is the scenario that achieves a peak in emissions around 2020 using only proven technologies without harming economic growth. It just cannot be. But where's the commitment to energy efficiency? And I must say, the New South Wales government last week is the first place in Australia that's announced something that actually has more than tens of millions a year allocated to this kind of change. When we're into the billions a year, we'll be serious. But that's pretty impressive, and I can tell you there's some other state governments that are scurrying around like mad trying to work out how they match these New South Wales people. And I describe this as competitive democracy, right? And we saw this competitive democracy a few years ago in the scramble to offer more and more attractive feed-in prices to get more and more votes at elections. And you can also see that competitive democracy can go wrong by getting over-generous with some things. But competitive democracy is a very powerful strategy that transcends economics. Now this slide is really just about cost reduction, and essentially what I said is projected costs are very uncertain, but basically everything that's important about a clean energy future is looking better. And the question of exactly how fast it will look better doesn't matter that much, because if you're smart, you're planning ahead on the assumption that it's all going to get better. And of course, if you look at what's called the marginal abatement curve that was originated by McKinsey, and this is the ClimateWorks one for Australia, all of those bars in the far side there that are below the zero line are the negative cost abatement measures. That is, they are the profitable abatement measures, and of course many of them are energy efficiency and many of them are not being pursued. I caused a bit of a stir at the EEC Council the other day at the conference where I explained to the Deputy Head of the Energy Efficiency area that the most aggressive scenario that had been presented in a recent consultation paper on commercial refrigeration had a benefit cost ratio of 7.8 to 1. And I suggested that there was a large opportunity cost between that and driving much more aggressive energy efficiency in that equipment so that we had a benefit cost ratio nearer to 1. Now, even that is financially attractive compared with the price we pay for emission reduction fund permits, which, you know, we're paying $12 a tonne for abatement. So there's a great, I mean, this is a wonderful thing. And again, it comes back to the fact that innovation, learning from doing, and economies of scale through mass production are transformative in terms of cost. We just have to get the right thing. We also have to get much smarter at understanding and evaluating costs and benefits. And I gave you the example before. How are these people comparing wholesale electricity at the power station with rooftop PV? It's mad. And, you know, most of our cost-benefit studies are just appallingly narrow. For example, in New Zealand, you know, they've found that the major benefit of a low-income home improvement, energy efficiency improvement program was improved health. You know, how much do you pay to visit your doctor compared with your energy bills, right? So there's lots of great stuff we can do to improve that. Now, the last couple of slides are about where to for APEC. I won't spend a lot of time on them because then we'll have some time for discussion, but it's interesting. I mean, this is my position, right? No one knows which options will be the winners, so we've got to have flexible strategies. We've got to send the right signals that encourage innovation in the directions we want. We have to support the emerging options to compete with powerful incumbent businesses. Right? This is a war, and the incumbent businesses are very powerful, and that's a problem for government. And of course, we have to manage disruption, inefficiencies and mistakes. And so, for example, I really think we need a much better mechanism to protect consumer rights as we move towards distributed energy solutions for homes. Because I could be in a home where I've got various technologies from maybe 5 different suppliers. You know, I've got a battery and some solar and some smart electronics and some different appliances. What if one of them fails? And we've got the solution. In Victoria, we have a no-fault third-party car insurance scheme where everyone's charged a levy. And if someone gets injured or broken up in a car crash, they get looked after. That's the first priority. And then we sort it all out, and we sort out whose fault it was and all those other things afterwards. That's what we need for the new energy economy. We need someone whose energy services are not being delivered to get them somehow, whether it's a portable generator or a long lead thrown over the fence from next door or whatever. We need people to be guaranteed that they'll be okay. And then we need a proper mechanism that works out whose fault it is, fixes it all up properly and funds it and all of that. And it's very cheap if we do it that way. That's why we've got the third-party car insurance mechanism that we've got, because it's really a good way to do it. So we need to think about where we're going with all those things. And then this is kind of stuff for APEC to focus on, you know, because a lot of countries need a lot of help. We've got developing countries, developed countries, we've got confused countries, we've got all these different ones that all need different forms of help. And then lastly, this was to frighten them because, of course, fossil fuel producing countries like Australia actually want everyone to use more energy, but most countries in the world are actually dependent on imports of energy, and the cost of all those imports is a problem, not a benefit. And I just sort of pointed out, well, for example, if you were interested in geothermal energy, there's a lot of countries around the world that have got access to a lot of geothermal energy that, you know, could free them up from dependence on funny countries like Australia. And, you know, what it really highlights is that even though Australia's got a fantastic solar resource, we have to make it all work and make it internationally competitive and, you know, tick all the right boxes if we are going to have a place in this future efficient, smart, disrupted, renewable world. And so it's really, you know, it's an exciting time to be starting to get into this sector. And you can see, you know, I'm still excited after 39 years because it's just an amazing time. So I'll stop the talk there and I'm happy to have discussion or questions. Do you want to drive it or we just...
For you too.
Oh, are you? Ah, this is the decentralised responsibility model, yeah. Okay, yeah.
So thank you for that talk. Obviously there's a lot out there in the future. But I'm partly playing sort of devil's advocate.
Many
opposing
yes.
But there's this idea that kind of Maslow's hierarchy of energy policy. And at the bottom is access, and then above that, I guess, is reliability. And these are kind of non-negotiables. The social preferences behind your energy system. Now, these are also big question marks about a distributed energy future. And the thing I noticed that was missing from your talk was any discussion about institutions and how, as a public good, you would have a set of institutions that would enable access, particularly to poor people, and reliability across the broad end.
We keep 12 million cars on the road, and we don't have that many institutions. It's a distributed system. Cars
don't have the set of operational constraints.
But you're assuming those operational constraints remain. If you free us up from some of the institutional blocks, you know, I could borrow some electricity from next door, or someone could park their electric car in my garage and plug in and give me some power. You know, this is, and in fact, institutionally, I did talk about an institution which was the concept of a fault, you know, no fault insurance mechanism to keep me going while we work out all the mess. So I actually had a virtual reliability security system proposed. So, you know, I think it was really interesting that the head of AGL was the person who came out and said, if you really want a reliable energy system, do distributed renewables, don't have a grid. So, you know, that's what's really interesting. We are talking about a world where we start at the end of services and things, and I absolutely agree. I want reliable energy services. But I don't see any particular reason why it should come from the kinds of institutions and technologies we have now. There's lots of other models. And that's what's amazing. And I think this is what's throwing the electricity industry, because when you've got Amazon and Google and Samsung and all of these people coming at you, where did they come from? They don't know anything about energy. No, but they know a lot more about people and a lot more about some technologies. And that's what's amazing about it all. So, other comments or questions? Yeah.
Thanks, Alan.
Sorry?
Thanks for this. You started out by saying that people are different, and that in Melbourne we need central heating, but in Africa people don't.
Well, not need. I said we interpret our need as those things. Because I don't need a centrally heated house because I've got a very efficient one that stays comfortable without it. But I was talking about stereotypes, and I was talking about perceptions of need and the way we think our need should be satisfied, which is driven by our past experience and by what we observe of what's normal around us about how other people do it. So maybe I wasn't clear enough there, but...
So, I mean, so the guys in Africa, can they have central heating?
Well, yeah, I'm not arguing about whether people should or should not have it. What I'm saying is that there'd be a lot of people in Africa who'd be pretty pleased to have some basic shelter. There are a lot of people in Australia who'd be annoyed if they didn't have their conception of comfort. But at the same time, we're all open to change. And so if you build a really good house that didn't need all the central heating and all of those hassles, a lot of Melbourne people might be much happier. So I wasn't saying what should be, and my view is we should all have high quality of life and productive lives. And there was a study done by a bunch of third world country people in 2008 where they actually estimated how much energy a household in a developing country would need for basic lighting, to charge their mobile phones, to run an education, iPad or something, run a micro business, provide a much better life. And if all of those 1.5 or however many billion people who don't have access to those things got them, it would add 0.5% to global electricity demand. So I'm not trying to say people shouldn't have good lives.
So if we developed it a bit further and we said that people in developing countries, because it seems like, here we can talk about services because we are service rich, yet kind of investment. We don't invest so much now because we built our roads and our railways and our aeroplanes. But maybe in a developing country, such kind of emphasis as services as the main consumer of energy is maybe not quite so I don't know, so real.
Well, so what you're saying is they need some physical infrastructure, for example.
The argument of efficiency works to an extent for services, but it works much less where you're talking about embodied energy. And when a country develops, they want to manufacture concrete and steel and aluminium.
Yeah, but see, you're trapped in the past. A lot of infrastructure, like for instance, a lot of people are into sustainable bamboo as an alternative to concrete. We're now building, 10 and 20-storey buildings using, compressed laminated timber. That's the physical, but beyond that, there's also is the virtual. For example, my understanding, and I haven't been to India, but I'm told that a lot of parts of India are leapfrogging having phone lines and are going straight to distributed mobile technology.
Yeah, most of Africa stopped doing that.
And I can see the dream, but
well, it's not a dream; it's a reality in India.
Hang on, I lived for about 5 years in northern China in an industrial city with about the population of London.
Yeah.
And it was cold and dark and dirty.
Yeah. Terrible.
And it was dark, and it was a major industrial town, and people's lives were getting better because they were working in factories using energy to make things that we consumed. And I would have had a real difficulty trying to explain to them that they should live in bamboo houses when I live here.
Yeah, but this is what's interesting about perception. Let me tell you that in the 1940s and 50s, a lot of people around Victoria lived in mud brick houses and hated them because they were a sign of poverty. In the 70s and 80s, a whole lot of trendy, wealthy people built mud brick houses because they were cool and trendy, and this is... anyway, look, all I can say is, I think what you need to do, I'm not saying you can solve all these problems today, but what I'm saying is you need to pull apart what are the services that we really want here, whether we're rich or poor or in the middle. What are the services I want, and what are the implications of the way I'm trying to satisfy them now compared with the ways that I could satisfy them in other ways? And I mean, I've just spent, 10 days in part of China where they are trying to move towards a services-based economy because they can't cope with the pollution. And as they educate the people, they all want a different world. And so the leaders are all trying to work out how do we extricate ourselves from this heavy industrial kind of past. It's amazing. I'm not trying to say people shouldn't have fantastic, productive, high-quality lives. And if that does mean we've got to build some more infrastructure for them, okay. But there's lots of different ways of doing it.
But we're going to reach zero carbon emissions by 2050 if we do that.
Yeah, because, for example, I was in this ASEAN workshop in China last year. And so they said, the average consumption is so much electricity consumption is so much per capita, and we reckon it's got to quadruple. And I said, well, hang on, that's more than enough to run a modern, well-designed, efficient economy, and a lot of it could come from renewable energy. So why are you telling me you need these enormous mega dams and nuclear power stations and power lines crisscrossing Asia? To me, that's the absurd dream. That's a capital-intensive system that takes a long time to build, that isn't necessarily very reliable. And to me, that's the pipe dream. But, I don't get invited to speak to the energy industry conferences, do I? Apart from the occasional one. So maybe I'm wrong, but, I'm just saying, think about it all. So, yeah.
You mentioned briefly about aggregate efficiency of economies. I think you mentioned it was around 12%.
Aggregate energy efficiency, yeah.
I'm just wondering, do you think that a prerequisite of us moving that up is electrification, or can we do it with existing fuel cells?
Well, I think a fair bit of it's electrification, but at the same time, I wouldn't want to. Green chemistry people are really smart. So, I have to say, I'm going off the gas grid, right? So I'm down to the one last thing I've got is this bloody stove and this $1,500 quote from my electrician. And then I'll be saving $300 a year on fixed supply charges from the gas company. And so, we could save a whole lot of infrastructure costs. So, so I think that's a path. But I'm open to all smart suggestions. Sorry, you were.
Yeah, so I saw your graph talking about the 40% of the energy usage goes to cooling and heating.
Yeah.
And then I think that graph has existed like the last 20 years, we all know that. And it looks like if you attack that, you can solve a lot of the energy problem. But why is it we still see that graph that cooling and warming, it's still 40% of total energy consumption, and it seems that nothing is done much about it?
Well, no, actually, Australian average household energy consumption's gone down quite substantially in the last 10 years. So having the same percentage doesn't mean energy growth. The second thing we have to keep in mind is that we only change a couple of percent of our housing infrastructure each year, and at the same time we have still had people building bigger houses. So there's a whole range of complex factors in there, and my view is that I don't take any end-use data on energy use in Australia very seriously at all. It's useful ballparks, but first of all there's enormous diversity from one to another, and second, we have such terrible end-use data, we don't know. I've just been trying to work out commercial cooking energy. And out of the very few estimates I can get, they vary by a factor of 3.
So is there enough conversation that goes on with builders and architects? I think, a lot of architects... Yeah, and instead of the energy minister, maybe, someone in government that, planning and built environment, because that seems to be where most of the energy wastage goes to. It's keeping us warm in winter.
Well, well, again, the reduction that I showed there in the heating and cooling came from the combination of better buildings and better technology for heating and cooling, the combination. They sort of multiply benefits. Look, we need a comprehensive strategy that touches on everyone who influences decision makers as well as decision makers. And that's one reason why I put up that long list of policy tools, because I reckon you work with everyone, you know. I mean, I worked on developing appliance energy labels and MEPs, and now, you know, for 10 years I've been saying now what we want is smart dynamic monitoring and warning of problems, because I've seen through my work how much equipment doesn't work properly. And so we keep learning and we keep needing to do more comprehensive and smarter policy. And the whole point is, we know what the outcome, we want a zero carbon or beyond zero carbon economy, and technically we know it's doable. We should just keep going until we get there, and if we're not making the progress we hoped, we go harder. But that's not a widely held policy view among policymakers in the world. Now, I'm conscious we're over. Are they going to? Yeah,
Oh, just a quick point, Alan. You can have a induction cooker that runs off an ordinary power point. I've got one, but it only has a single ring.
Well, I actually have one too, and it's not meeting criteria of other people in my life. Yes.
Okay, well look, it is 2 o'clock, and no doubt some of you need to be somewhere else. But please join me in thanking our